Good evening, Bhavishya. Good evening, Swati.
Good evening, ma'am.
Good evening. Good evening. So, have you both completed answer 7 and 8 in
Yes,
your
ma'am.
tuition notebook?
Yes, ma'am.
Okay, fine. So, I have to
Yes, ma'am.
explain this. Yeah, very good, both of you. So, the question is, I haven't explained these two answers, children. So, we'll see that now. If each edge of a cube is doubled, if each edge of a cube is doubled, each edge meaning the length, breadth, and height. And we know that in a cube, the length is equal to the breadth is equal to the height. Each breadth, each edge is doubled. That means the length, breadth, and the height, they're all doubled. Okay, how many times will its surface area increase? Now, supposing the edge of the cube is 4 centimeters, it's doubled. That means it's now 8 centimeters. So the length is 8, the breadth is 8, the height is 8. Initially, the length was 4, breadth 4, and height 4. Now the edge is doubled. Each edge is doubled. Each edge meaning the length, breadth, and height. Okay, when it's doubled, how many times will its surface area increase? And also, how many times will its volume increase? So how do you work this? So see here, edge of the original cube. Let the edge of the original cube be A units. Let the edge of the original cube be A units. So the edge of the new cube, it's doubled, right? So it is 2A. It's doubled. That means A plus A, 2A. Or doubled is also A into 2 or 2 into A. It's doubled. So the new edge or the edge of the new cube is 2A units. A, and now it's 2A. Now first let's answer this question, surface area. So surface area of the original cube. What is the surface area of the original cube? 6A square units. Surface. So when it is simply surface area, it's always the total surface area. When it is surface area, it's always the total surface area if nothing is mentioned. So the surface area, meaning the total surface area of the original cube, is 6A square units. Now the surface area of the new cube will again be 6 into edge square. 6 into edge square, the new edge square. 6 into the new edge square. See, what's the formula to find the surface area of a cube? 6 into edge square, whatever is the edge square. That's what we say, 6A square. Okay, so now what's the new edge? What's the new edge? It is 2A. So 6 into 2A the whole square. The edge is now 2A, it's doubled. So 6 into 2A the whole square. So 2A the whole square is nothing but 2A into 2A. So that is 2 to the 4. A into A is A square, 4A square. So now the surface area of the new cube is 24A square units. Now see here, what is the surface area of the original cube? 6A square. It's now become 24A square. How? Because it's become 4 times now, into 4. It's become 4 times. See here, this is the surface area of the original cube. Now the surface area of the new cube is 24A square. So what's happened? The original surface area into 4 is the new surface area. The original surface area into 4 is the new surface area, 24A square. So that means the new surface area is 4 times the original surface area. The new surface area is 4 times the original surface area. Is that correct, children? The new surface area is 4 times. How many times? How many times will the surface area increase? So the new surface area is 4 times. It increases by 4 times. The new surface area is 4 times the original surface area. Is that fine, children?
Yes, ma'am.
Okay. Now let's work volume. The volume of the original cube. What is the volume of the original cube? That is, original cube is small. The new cube is big because the edge is doubled, right? Original cube is small. The new cube is big because the edge is doubled. Okay, so the volume of the original cube, A cube cubic units. The volume of the new cube is with the new edge. Okay, the volume of the new cube will be 2A the whole cube. What's the formula to find the volume of a cube? Edge cubed. Edge the whole cube. Or we say side or A cube. So the side is 2A. It's not 2A cube like this, children. whatever is the side, whatever is the edge, you must cube it completely. So it's going to be 2a the whole cube. So it is 2a into 2a into 2a, which is 8a cubed. 2 2s are 4, 4 2s are 8. 8a cubed, a into a into a. So how do you multiply? A to the power, base are same and its multiplication. Add the powers, 1 plus 1 plus 1, which is a cubed. 8a cubed. 8a cubed cubic units. So the original, that is the volume of the original cube is a cube. And now the volume of the new cube is 8a cubed. So it's now 8 times into 8. A cubed into 8 is 8a cubed. So the new volume is 4 times, or sorry, 8 times the original volume. The new volume is 8 times the original volume. Is that fine, children?
Yes, ma'am. Yes, ma'am.
Yeah. This one, water is pouring into a cuboidal reservoir at the rate of 60 liters per minute. So that means in 1 minute, 60 liters of water is being filled into the reservoir. In 1 minute, 60 liters of water is filled into the reservoir. If the volume of the reservoir is 108 meter cubed, find the number of hours it will take to fill the reservoir. So you just have to convert the volume. See, the volume of the reservoir is given to you. Convert that volume to liters. Convert that volume to liters. Now, see, it's very simple. Now, it's like this. Now, you know that 60 liters of water is filled in 1 minute. It's filled in 1 minute. Now, supposing the reservoir can hold, say, 300 liters of water. The reservoir, say, can hold 300 liters of water. Then how long will it take to fill?
I'm 300 by 60.
Sorry?
I'm 300 divided by 60.
300 divided by 60. So it takes
5
5
minutes.
minutes. 5 minutes. So if 60 liters of water is filled in 1 minute, and supposing the volume of the reservoir, yeah, please disable your mics. And if suppose the volume of the reservoir is 300 liters. So 60 liters in 1 minute. 300 liters in how many minutes? So 300 by 60. So 5 minutes. So now the thing is here, the volume, see now in my example, I gave the volume of the reservoir in liters, 300 liters. In this example, I gave the volume of the reservoir in liters. So it was easy to calculate the time taken to fill the reservoir. 60 liters in 1 minute. And the volume of the reservoir is 300 liters. The capacity is 300 liters. So that will take 5 minutes. But here the volume is given in meter cubed. The difference is here the volume is given in meter cubed. Instead of giving it in liters, it's given in meter cubed. So first step, convert the volume or the capacity of the reservoir, which is given in meter cubed, to liters. That's all. That's all. The volume of the reservoir is given in meter cubed. Volume is nothing but the capacity of the reservoir. It's a capacity of the reservoir. That is 108 meter cubed. So we don't understand what is 108 meter cubed. But we understand liters. 1 liter, 2 liters, we can imagine. So we see the milk packets, right? So you know how much of milk is in a half liter packet of milk. You can gauge, like, you know, so some 2 to 2.5 tumblers, the normal sized tumblers, you know, so some 2 to 2.5 tumblers, half a liter. It depends on the size of the tumbler, but I'm just telling you, you can gauge it. So when the capacity is told to you in liters or milliliters, you can gauge. Now, if I say 20 ml, 20 ml, so we have all had medicines, no, in that cap, 5 ml of medicine. So you know how much is 5 ml. So like that, you can just imagine 20 ml. If I say 20 ml of liquid, 20 ml of liquid. So you immediately get that, you know, a medicine cap in your mind, and that medicine cap, if fully, it is mostly 10 ml. So twice in that is 20 ml. So when it is when the capacity is expressed in milliliter or liter, it's easy for us to understand. But when it is in meter cubed, we can't gauge. 108 meter cube, no, we have no idea how much that is. Whether it is too much or too less, we have no idea. But when you convert that to liters, it'll be very clear. So first, so what you have to do is you just have to convert that volume which is given in meter cube to liters. If you do that, you are almost done with the answer, because once you find the capacity in liters, 60 liters 1 minute, so many liters how many minutes, that's all. So see here, so that's all. So this is that calculation part which I've shown in detail, converting meter cube to liters. So see here, volume or the capacity of the reservoir is 108 meter cube. So I told you, you may even skip this. 1 meter cubed is 1000 liters. 108 meter cubed is how many liters? X liters. I've told you this. You can also write it like this. 1000 liters. 1000 liters is 1 meter cube. Like this also you can write. 1000 liters is 1 meter cube. Then how many liters is 108 meter cube? We discussed this in the last class, children. Can you recall this? Is this clear?
Yes, ma'am.
You should have liters in the numerator and meter cubed in the denominator, or meter cubed in the numerator and liter in the denominator. Okay, so maybe you can skip this one. You can write this 1 meter cube, 1000 liters, 108 meter cubed, how many liters? X liters. So cross multiply. X into 1 is equal to 108 into 1000. So X into 1 is X. X is equal to 108 followed by 3 zeros, liters. So many liters. So you can understand 1,08,000 liters. My God. Okay, so 1,08,000 liters. So oh, that's really a huge volume. So we found, so it's very simple. What we have done here is we have converted the capacity of the reservoir, which was given in meter cube, to liters. That's all, nothing else. Now it's easy to calculate. Now 60 liters in 1 minute. 1,08,000 liters in how many minutes? That's all. It's just converting. See here again. You may or may not write this. This is just your choice. You can write this straight away. 60 liters. See, it's given here 60 liters per minute. So 60 liters in 1 minute. 1,08,000 liters in Y minutes. That is, see here. 60 liters of water is filled in 1 minute. 1,08,000 liters of volume. 1,08,000 liters of water will be filled in how many minutes? Y minutes. So cross multiply. 60 into Y is equal to 1,08,000 into 1. So Y is equal to, you can see this 1,08,000 divided by 60. On simplifying, you get 1,800. It will be minutes because Y minutes. Okay, so 1,800 minutes. How do you convert that to hours? You should divide by 60. Divide by 60. So you get 30 hours. So the reservoir will be filled in 30 hours. Isn't it simple, children?
Yes, ma'am. Yes, ma'am.
Okay. So with this, we finish all examples and exercise problems from NCERT. Okay, of the chapter mensuration. We also did a few sums outside NCERT in the middle. Now and then we did it between the exercises. Now what I want Swati to do is, since your school follows Exceed, please take pictures of this chapter mensuration from your book and share it with me on WhatsApp, so that I'll include those questions also, and we can discuss them in the next class. If there's something different in Exceed, then I can make a presentation of that, and we can discuss that in the next class. All right, Swati, don't forget, please do that. You have dinner today and send it to me without fail. Is that fine, Swati?
Yes, ma'am.
Okay.
Yes, ma'am.
Only of this chapter, mensuration.
Yes, ma'am.
Yeah, both from your textbook and workbook. So, both your textbook and workbook. All right.
Ma'am.
Yes, Bhavishin.
Ma'am, can you send me the answers for the worksheet, ma'am?
Oh, yeah, I forgot. Yes, yes, Bhavishya. I'll do it today. I'll do it today. Sorry.
Okay, ma'am.
Yeah, yeah, yeah. Oh, Bhavishya, can you send me the questions again, Bhavishya?
Okay, ma'am.
Sorry, sorry. Please send it again. I'll do it today.
Yes, ma'am.
Yeah. Bhavishya, your school follows NCRT, right?
Yes, ma'am.
Okay. So for you, mensuration from NCRT is done. Examples and all exercise questions.
Okay, ma'am.
Yeah. Now it's time to take a test. Yeah. Yes. Try this one, girls. You can refer. You can use your classwork, go through an answer which is similar to this, and then try this because we are only practicing. Okay. So we have done a similar question in the class. So flip back some pages and find a question similar to this, see how it has worked, and then try this. Yeah. Write down the question first. Yeah, Swati and Bhavishya. Started working?
Yes, ma'am.
All right.
Yes, ma'am.
You were able to find a question similar to this in your notebook?
Yes, ma'am.
Yeah, please. We'll have to be careful with the units. 91 centimeter, 1.25 meters. So convert meter to centimeter, 1.25 meter to centimeter. Yes. Can we discuss the answer, children?
1 minute, ma'am.
Okay. Yes, children. It's okay, enough. Whatever you worked, please share. What have you first found? Yeah, Bhavishya.
Yes, ma'am. We have to. I mean, I have taken CEC of the.
Curved surface area.
Yes, ma'am.
Okay. So curved surface area. Curved surface
Yes.
area of the roller. Of the roller is equal to, what's the formula?
2 pi r h, ma'am.
2 pi RH square units. Very good. Then 2 into
2 into 22 by 7 into 91 by 2, ma'am.
yeah.
Into 1.25 by 100.
Oh, 1.25 by 100.
Like that I have done. After that only I have
No, no, no. What is 1.25 by 100?
125.
No. 1.25 by 100 is not 125. 1.25. See, It's 1.25. When you divide by 100, you know what you will get? 0.0125. See, remember when you're dividing by 100, the number will become smaller, right? How will it become 125? When you're dividing 1.25 by 100, it's just 1. 1.25 is just 1. When you're dividing that by 100, how can you get 125? No? So what you should have written, tell me?
1.25 by 100, after that I have cancelled that.
No, Ma, you cannot write 1.25 by 100. See, this is what it is. You should not substitute in meters at all here. You should substitute in centimeter. For that, you work here itself. 1.25. No, disable your mic, Bhavishya.
Yes, ma'am.
Yeah. So see here, 1.25 meters. Convert that to centimeters. 1.25 into 100 meter to centimeter. Multiply by 100. Which is 125 centimeters. So you should substitute 125 here. All right, Bhavishya?
Yes, ma'am.
Yeah. Now, how do we simplify?
Ma'am, 1, 2 is 2 and 2 and 2 cancel, ma'am.
Okay.
1, 7 is 7, 13 7s are 91.
Very good. Now we should find this product, right?
Yes, ma'am.
Find this product. So 22 into 13 into 125. Okay, so I have a calculator beside me. 22 into
35,750.
35,750. 35,000, yeah, 750. What? Centimeter cubed or meter cubed? Sorry, centimeter square or meter square?
Ma'am, centimeter square.
Centimeter square. Yeah, Swati, centimeter square. Now, what will be the area of the road? Area of road is equal to?
I'm 750.
750
pi RH.
750 into?
2 pi RH, ma'am.
2 pi RH.
No, that's what. Now you found 2 pi RH. So area of the road is equal to CSA. CSA into 750.
35,750.
CSA of the roller into CSA of the roller into number of revolutions. Into number of revolutions. So CSA, you got it, 35,750 into the number of revolutions, 750. So that is
20.
into 750 into 750. Oh my, it's a huge number. 268,125 followed by 2 zeros. Centimeter cube. Oh, sorry, centimeter square. You can divide, you can convert this to meter square. How do you convert this to meter square? How do you convert this to meter square?
I'm divided by 10,000.
10,000.
Yeah. So I'm continuing here. So that is equal to 26812500. When you divide this, to convert centimeter to meter, you divide by 100. To convert centimeter square to meter square, you divide by 100 two times like this. So it's converted to meter square. So 2 zeros and 2 zeros gets cancelled. So the answer is 2681.25 meters square. This is the area of the room. 2681.25. 2 zeros, these 2 zeros get cancelled and then again divided by 100. So you place a decimal point here. Yeah. You might have worked it, children. If you have to do some corrections or whatever, please do it.
Ma'am, I can't understand why they are doing like CSA into the number of revolution, ma'am, to find the area of the road.
Correct. Now, which part of the roller will roll on the ground? Which part of the roller? Now, a road roller it's cylindrical. You must have seen a road roller. The wheel is cylindrical. Now, what now? When we say a road roller, it's cylindrical. It has both, curved surface area and total surface area. Total surface area is the CSA and the area of the two circles. Now, in the case of a road roller, only the curved surface area will roll on the ground, correct?
Yes, ma'am.
Yeah. So only the curved surface area will roll on the ground. So in one revolution, just think about the road roller. Just think about the road roller. In one revolution, the area covered is 2 pi RH. Because in one revolution, once the CSA will roll on the ground. Curved surface area, that's also area. In one revolution, the curved surface area of the roller will roll once over the ground. So whatever is the CSA of the roller, that area will be covered on the road. Now imagine a long road, all right. When the roller moves once, that is when it makes one complete revolution on the road. What is the area covered is the question. When the roller completes one revolution on the road, what is the area covered? In one revolution, the curved surface area of the roller would have moved once over the road. So whatever is the curved surface area of the roller, that area of the road is covered. In one revolution, whatever is the curved surface area of the roller, that area is the area covered on the road in one revolution. So area of the road in one revolution is 2 pi RH. So the area of the road, the whole road, meaning the entire road, will be the number of revolutions, 750 into CSA. CSA is the area in one revolution. So the complete area will be CSA into number of revolutions, 750. The area covered in one revolution is CSA. So the area covered in 750 revolutions will be the area of the road. Is that okay? Okay. Yeah. We don't find the total surface area because the two circles, they will not roll over the ground. The two circles on either ends, they will not roll over the ground. Only the curved surface area will move over the ground. So the area covered in one revolution is CSA. In 750 revolutions will be CSA into 750. And that is the area of the road. That will be the area of the road. Now, supposing you get CSA as a fraction, don't divide, just take the fraction further. Now, CSA, supposing you get a fraction, don't divide and find the decimal value. Take the fraction in the next step. So CSA of the roller, substitute that fraction into 750. Yes, Swati? Anything else?
No, ma'am, no doubts.
Okay. What about Bhavishya?
No doubts, mom.
Bhavishya, but why did you write 1.25 by 100? I'm not able to explain that. Can you ask me your question?
Mom, actually I have before one sum I have done like that, mom. 1.25 by 100, and I have taken the decimal point to that another. After the 25 25, mom. So like that I have done in this question
No,
also.
please understand. Is this clear, Bhavishya?
Yes,
Is this
ma'am.
one clear?
Yes, ma'am.
Okay, fine. Okay, children, this is your next question. So I said you can refer. You can refer. Please refer. All right, Bhavishya and Swati, what do we mean by the thickness of the metallic tube? It's given by which letter? How do you represent the thickness?
W, ma'am.
W. W is equal to 1 centimeter. Very good. Then inner diameter, small d or capital D? Inner diameter.
Small d, ma'am.
Small d. Inner diameter, small d. Outer diameter, capital D. Inner radius, small r. Outer radius, capital R. Okay. So inner diameter, that is small d, is 12 centimeters. So that means what is the inner radius?
6 centimeter, ma'am.
6 centimeter. Now what should you find? You know width and you know the inner radius. What should you find next?
Radius.
The outer radius. Outer radius. How do you find the outer radius?
Ma'am, we should divide 12 by 2.
Ma'am, W plus the inner radius, ma'am.
Yeah, inner radius plus the thickness. Inner radius plus the thickness. See here. This is the inner radius. This is the thickness. The inner radius plus the thickness is the outer radius. The inner radius, I told you, remember any one. See, maybe you can remember this. The outer radius is inner radius plus the thickness. I also told you thickness is outer radius minus inner radius. Inner radius is outer radius minus the thickness. You have it in your book, all of you, meaning both of you here. Yeah, children. So, Swati, you're right. Outer radius is inner radius plus the thickness. So that is
7 centimeter, ma'am.
6 plus 1, 7 centimeter. Very good. Now, will you find the volume now for a metallic tube, which is a hollow cylinder? You can find the volume, you can find the curved surface area, you can find the total surface area. Now, what will you find in this situation? Will you find volume, CSA or TSA?
Ma'am, volume.
Volume, ma'am.
Because we have to find the weight of 1 meter long tube. So, what's the height of the tube?
1 meter, ma'am.
1 meter.
1 meter. 1 meter. The height of the tube is 1 meter. Now 1 meter means how many centimeters?
100 centimeter.
100 centimeters.
100 centimeters. So these are the values. When the question is about a hollow cylinder, these are the values you need. What is small r? What is capital R? What is H? You need these three values. If you have these three values, you can answer any question related to the hollow cylinder. So now we have all these values. We have found all these values. Okay, now Swati said you will find, she'll find volume. Now, why volume? Because it's given 1 centimeter cube. So 1 centimeter cube means volume. 1 centimeter cube of the metal has a density of 7.8 grams. So supposing this tube is say 10 centimeter cube, has a volume of 10 centimeter cube. Supposing this metallic tube has a volume of 10 centimeter cubed. So 1 centimeter cubed, 7.8 grams. Then 10 centimeter cubed will have a density of 7.8 into 10. So 78 grams. That's all. Yes. Now tell me ahead.
Ma'am, then the volume equals pi capital R square H minus pi small r square H, ma'am.
Yeah, volume of metallic tube is equal to pi capital R square minus small r square into H, correct?
Yes, ma'am. Ma'am, as we use distributive property, ma'am, we get pi H into R square into capital R square minus small r square, ma'am.
No, you should not use a distributive property. You should substitute it as it is. So 22 by 7 into what is R square?
Ma'am, that's what, ma'am. That's like pi capital R square H minus pi small r square by H. I told that we can use the distributive property to shorten it, ma'am.
You're saying you should write pi R square H minus pi R square H, is it?
Yes, ma'am. After that, I told that we can use the distributive property to shorten the formula, ma'am.
What will you use now?
Ma'am, pi and h will come, since they are common, they will come out, ma'am. And r square, ma'am.
No, that's not common there, okay? Because see here, that's already, it's like this, you know, you have A into B minus C into D. You're just bringing, it's okay, you have 2 into 3 into 4. So you're just writing the 4 front, 2 into 4 into 3. You're just changing the position. Maybe you can say commutative property. Sorry, associative property. Maybe you can say associative property. That is pi into r square minus r square into h. Oh, we know that it's the same as pi h into r square minus r square. You can write that h here also. It's not common. We are not taking anything common there. If you want to relate it to a property, it's the associative property of multiplication. Why associative property? Because you don't have to talk about properties here, but I'm just telling you, see here, you write pi h into r square minus r square, or you can write pi r square minus r square into h. Both are the same. There's no property here. You can write the h behind here, or you can write it in the front here. It's a product. Pi into h into r square minus r square, or you can write pi into r square minus r square into h. It's a product. All right. Now substitute, children. What is the value of capital R?
Ma'am, 7.
7 centimeters. 7
Yeah,
square.
7 square minus
6 square.
6 square
square,
into
100.
into 100 into 100. Let me work here. Let me just continue here. So that's equal to 22 by 7 into what is 7 square?
49.
49.
Minus
36.
36 into 100
100.
into 100. You can write into 100. So that is equal to, you should please continue below this. I don't have place on writing here. 22 by 7 into what is 49 minus 36?
13.
13
into
ma'am.
100.
200.
Yeah. So you can just take it like this. You can just leave it like this, or you can multiply the numerators. 22 into 13 into 100 into 100. So my calculator says 28,600. 28,600 divided by 7, because you cannot simplify further. Now don't divide this. You know, when you divide, it will not be exactly divisible. Don't divide this further. So many centimeter cube. This is the volume of metal. Okay, now 1 centimeter cubed. 1 minute. Yeah. 1 centimeter cubed of pipe. It's a pipe, right? Or a tube. Okay, of tube. 1 centimeter cube of metal has a density of 7.8 grams. So 28600 centimeter cubed by 7 centimeter cubed of metal will have a density of 28600 by 7 into 7.8 grams, correct?
Yes, ma'am.
Yeah.
So we can write it as 78 by 100.
Yeah,
So
next
that
step.
we can
78
cancel
by
the zero.
78 by 10.
100. I mean 10.
Yeah, you can. Yeah. So 28600 by 7 into 78 by 10 grams. So 0 and 0 gets cancelled. You cannot simplify this. So now multiply and divide and get me the answer in grams, children, and then convert that to kilograms. Yeah, please work.
Ma'am, can you show me that before slide now?
Yeah.
Thank you.
Yeah. Yes, Bhavishya?
For this, I have done like small r is equal to W minus big R, like that I have done.
No, let's understand that clearly. See here. This is the disable your mic, Bhavishya. Yeah. Now see here. These are the two concentric circles. This is the inner radius. This is the thickness from here to here. This is the thickness W. And you know that this is capital R. This only is capital R. So what is capital R? It is small r plus W. Yeah. And see here, what is this width? Now from here to here is capital R. And from here to here is small r. So this width will be capital R minus small r. Capital R minus small r is the width. From here to here, this one is the outer radius. From the outer radius, if you take away the inner radius, you will get the width. Outer radius minus inner radius is the width. And if you want to get the inner radius, it's the outer radius minus the width.
Okay, ma'am.
Yeah. Tell me this answer.
Ma'am, in kilograms, I'm getting like 5,577 by 175 kilograms.
What is the product actually? The new product of the numerators? Is it 223,080 by 7?
Yes, ma'am. Yes, ma'am.
So when you divide by 7, what do you get?
Ma'am, that's the decimal keeps on going. Ma'am. So
31868.571 grams. So when you divide by 1000, 31868.571 divided by 1000. Then it's changed to kilogram. And the final answer is, when you divide by 1000, you get 31.868 kilograms. 31.868 kilograms.
yes, ma'am. In fraction, we get 5,500. In fraction form, we get 5,577 by 175, ma'am.
In fraction, you get what? 5,000?
577 by 175, ma'am.
175. Oh, how did you get 175 in the denominator?
Ma'am, I simplified to 22,308 by 700, ma'am.
Oh, okay. 0 you cancel, and then again it's divisible by 2. So you divide it by 2, still you will get 70 and 35 only. Now, how you got 175?
Ma'am, it's like 11,154 by 350, ma'am.
Oh, 7,000 it is, no? Yeah, 10, and then it's 700. Oh, you do. Oh, yeah, fine. Yeah, fine. So tell me a fraction. Let me divide and see if you're getting the same answer. Tell me your
Yes, ma'am.
fraction.
5,577 by 175.
Yeah, perfect. 31.868. Perfect.
Yes, ma'am.
Yes, Swati. Swati,
Yes,
I told
ma'am.
you to send the pictures. No, don't forget. Huh?
Yes, ma'am.
Yeah. Both from your textbook and your workbook.
Okay, ma'am.
Yeah.
Ma'am,
And what about the
mensuration.
question? Sorry?
Ma'am, mensuration, I think it's in volume 2, ma'am, because in volume 1 I'm having like.
That's okay.
Uh,
Whichever, wherever it is.
yes, ma'am.
Yeah. Wherever it is. Yeah. And Swati, what about the question paper?
Ma'am, I still can still get. I didn't get it, ma'am. I was searching for it. I think in one of the book I submitted it, ma'am.
You can just ask your friends, no, to send a picture.
Yes, ma'am.
Yeah, you can ask your friends to send a picture and you can share the same thing with me.
Okay, ma'am.
Yeah. Okay. Please do that, Swati. I'm looking forward to the paper.
Yes, ma'am.
Yeah. Yeah, children, any questions here? Okay.
No, ma'am.
All right. Completed? Shall we go to the next one?
Yes, ma'am.
Yes, ma'am.
Okay. Yeah. An iron pipe 20 centimeters long has exterior diameter 25 centimeters. If the thickness of the pipe is 1 centimeter, find the whole surface area of the pipe, not volume, whole surface area. So you should find you remember one sum we did, inner CSA, outer CSA, area of two rings. We found everything in terms of pi. We did not use the value of pi. We found everything in terms of pi. Then we added all these three results. And once for all, we substituted the value of pi. Refer to that sum. Please refer and work it. Can we see the answer, children?
No, ma'am.
Okay. But you're doing it right, no? Okay, let me get the basic values. Yeah. Please tell me the values of small r, capital R, and H. What is given in the question? Exterior diameter. So which letter represents exterior diameter?
Capital D, ma'am.
Capital D. Capital D is how much? 25 centimeters. Okay, then what's the value of capital R?
Ma'am, 12.5 centimeter.
Okay, you can take this 12.5 or 25 by 2 itself, whatever. You can take anything, or you can take 12.5 centimeter. Both are correct. Okay. Now then, what is the thickness of the pipe?
1 centimeter, ma'am.
Yeah. So letter
W.
W is equal to 1 centimeter. So you have capital R and W. So what should you find using these two?
Small r, ma'am.
Yeah, small r is equal to
12.5 minus 1, ma'am. 11.5 centimeter.
W. Very good. So 12.5 minus 1.
11.5 centimeter, ma'am.
11.5 centimeter. Or if you want to take the fraction form, you can also do it like this. See here. You can also do this, children. So 25 by 2 minus 1 minus 1. So it will be 25 minus 2 by, on taking the LCM, 25 minus 2 by 2, 23 by 2. 23 by 2, which is nothing but 11.5 centimeter. So to substitute, you can either take 23 by 2 or you can take 11.5. 23 by 2 or 11.5. Okay. Now what's the height of the pipe?
1 centimeter, ma'am.
20 centimeter.
I mean 20
20.
centimeter.
20 centimeter. The height or the length of the pipe. See, when it's a pipe, we don't say height, but here in the formula, we have the letter H, okay? So it's actually the length of the pens. See, now when you have a pencil with you, okay, a pencil, okay, or a pen, you don't say height of the pen, or you don't say height of the pencil. You say, because we normally hold it like this, we say length of the pen or length of the pencil. So length of the iron pipe, length. But when you keep it like this, vertically, it is height. When you keep it horizontally, it is length. When you keep the same thing vertically, then it becomes height. So length, height, both are the same, 20 centimeters. Now we need to find the whole surface area. So what are you finding? Did you find the inner CSA? Fine. Please do it. Show you one sample. So inner CSA is equal to 2 pi RH square units. So 2 into pi into radius small r 23 by 2 into H 20. So 2 and 2 gets cancelled, and 23 into 20 is 46, meaning 460 pi centimeter square. Did you all get this inner CSA?
Yes, ma'am.
Very good. Similarly, find the outer CSA. And then the area of two rings. Yeah, let me know once done, children.
Ma'am, I'm getting 500 square centimeters. 500 square units, ma'am.
Or
Ma'am, for outer CSA.
500, huh? Okay, let's work. Yeah. Let me check. So outer CSA is equal to 2 pi capital R H square units. So 2 into pi into capital R, I forgot. What is it? 25 by 2. 25 by 2. 25 by 2 into height. So 2 and 2 gets cancelled. Yeah, 500 pi. 500 pi centimeter square. Now area of two rings. Area of two rings. Area of one ring is what is the area of what is the formula to find the area of one ring?
Ma'am, 2 pi r capital R square means.
Ma'am, for one
ring.
Ma'am, one ring it's pi
Ma'am,
pi
pi r
into R square, capital R square minus small r square.
Pi capital R square minus small r square. Two rings will be 2 into, or you can just write 2 pi. You can write 2 into, or you can write 2 pi. Correct. Area of two rings. 2 into, or simply 2 pi r square minus r square square units.
Ma'am, I got my final answer, ma'am.
Very good. 2 into pi into, yeah, 1 second. 1 second. Let me just finish this. Capital R square. So 25 by 2, the whole square. Minus small r square. 23 by 2, the whole square. Okay, so 25 by 2 the whole square minus 23 by 2 the whole square units. Yeah, what is your answer, Swati, for area of two rings?
Ma'am, area of two rings?
Yeah.
48 pi, ma'am.
48 pi, is it?
Yes, ma'am.
Okay, let me see. Okay, so that is equal to 2 into pi into 25 square is 625 divided by 2 twos are 4 minus 23 square is 529 divided by 4. So 2 into pi into 625 minus 529 divided by 4. So that is equal to 2 into pi into using my calculator minus 625. I'm getting 96 by 4. 96 by 4. And 96 by 4 is 24. So 2 into pi into 24. So what did you get, Swati? 48 pi you said, no?
Yes, ma'am.
Very good. 48 pi centimeter square. 48 pi centimeter square. So substitute children.
Doing this.
You can use the formula a square minus b square is equal to a plus b into a minus b. Is that what you're trying to say?
No, ma'am, you are finding it separately, no, ma'am. I just used the formula whole sum, ma'am, and then substituted the value for all.
For which one? For area of two rings, is it?
No, ma'am, for all, ma'am, like 2 pi h of capital R plus small r and then plus 2 pi into capital R square minus small r square, ma'am.
That is, you wrote the formula to find the TSA of
Yes, ma'am.
hollow cylinder. Yeah, you can do it. Then how did you get 48 pi separately?
Ma'am, that's what, ma'am. Like first, I found the value of 2 pi h cap into capital R plus
You
small
put
r.
plus in the middle. You put
Yes,
okay.
ma'am.
Oh, okay. Yeah. That's fine. Yeah.
Yes, ma'am. And then I kept the value of pi as it is, ma'am. And at last, I just substituted it with 22 by 7.
Correct. Yeah. Okay.
Ma'am.
So I'll just explain what I have done. So 2 into pi into r square. So 25 by 2 the whole square minus r square. 23 by 2 the whole square. Now, how do you find the value of 25 by 2 the whole square? 25 square is 625. 25 by 2 the whole square means 25 by 2 into 25 by 2, which is 625 by 4. Similarly, 23 by 2 into 23 by 2 is 529 by 4. Yes or no? Swati and Bhavishya?
Yes, ma'am.
Yes, ma'am.
Okay, so that's what I've written in the next step. Then taking the common denominator. 4 is a common denominator, so 625 minus 529 by 4. 625 minus 529 is 96. 96 by 4, which is 24. Yeah, and 2 into pi into 24 is 48 pi centimeter square. Now, the TSA. So you can call this 1, 2, and 3. You can call this one. You can call this answer 1. You can call this answer 1.
Ma'am, I have found TSA, ma'am.
Yeah, 1. You can call this 2, this answer 2, and this 48 pi, this answer 3. You can call this answer 3. You can call this one 3. Yeah. So now TSA, total surface area of the metallic tube, right? Is it called the metallic tube? Yeah. Oh, iron pipe. Sorry, it's the iron. No, which one are we doing? Yeah, iron pipe. Oh my God. Oh yeah, no, sorry. Where am I? Yeah, this someone. No, I'm confused with the question. I'm like wondering which question are we doing? This one, right?
Question
Okay,
number 4.
yeah, iron pipe. Yeah. So TSA of iron pipe is equal to 1 plus 2 plus 3. 1 plus 2 plus 3. So what did we get in 1? 48 pi, yeah? 460 pi. 460 pi plus 500 pi plus 48 pi. 460 pi plus 500 pi plus 48 pi. 48 pi. So 500, 900, 960, 1000, 1008. 1008 pi. All of you got this?
Yes, ma'am.
Yes, ma'am.
Yeah, so 1008 into 22 by 7.
7.
Yeah, so 1008 divided by 7. Is it divisible? Yeah,
Yes,
144 times. 144 times into 22. That is 1008.
3060.
Ma'am,
Yeah,
3,168.
you can cancel this 1 and 144 times into 22.
Centimeter.
Into 22. Yeah, 3168.
3168 centimeter square, ma'am.
Very good, very good. Yeah. To show you. Yeah, very good.
Ma'am,
Yeah, 1 second. I'll just take photos of this one. Just 1 second. Yes, Bhavishya.
Ma'am, I'm having
Yes.
doubt. Ma'am, I'm having doubt in area of 2 rings.
Area of 2 rings. I'll tell you. Yeah.
Ma'am, how 2 into 5 into 96 by 4?
No. I'll tell you. No. I'll not come from there. Wait. You listen to this. Can I clear the slide, children?
Yes, ma'am.
Yes, ma'am.
Okay. Now see here, Bhavishya. Tell me, how will you find the area of the shaded region? It's the shaded region. Okay. This is 20. This is 10. This is 10. This is 5. Yes, Bhavishya, how do you find the area of the shaded region?
Ma'am, L into B into H.
L into B into H. Huh?
Yes, ma'am.
Swati, how do you find the area of the shaded region?
Ma'am, L into B.
Ma'am, area.
L into B, correct, Bhavishya.
Ma'am, capital L into B minus
Yeah.
L into.
Yeah. Area of the outer rectangle minus the area of the inner rectangle. Do you understand that, Bhavishya?
Yes, ma'am.
Area of the shaded region is equal to area of the outer rectangle, that is LB. L into B, capital L into capital B, minus area of the inner rectangle, small l into small b. Area of the outer rectangle minus the area of the inner rectangle. Yes or no?
Yes, ma'am.
I'm using capital L, capital B for outer rectangle, small l, small b for inner rectangle. So area of the outer rectangle area is L into B. So capital L into B minus small l into B will be the area of the shaded region. In the same way, when you have two circles like this, disable your mic, Bhavishya. When we have two concentric circles like this, how do we find the area of the shaded region? Now we have to answer, Bhavishya. How do you find the area of the shaded region? Like you did for the rectangle now, the shaded region between the rectangles.
Yes, ma'am. Ma'am, pi r
Yeah.
square.
No, I don't want the formula. I want in words. Area of the,
Ma'am, area of the inner circle minus outer circle minus inner circle. Ma'am.
okay. See, in the earlier example, it was the area between two rectangles. Now here it is the area between two circles. So, no, disable your mic, Bhavishya. I got the answer from you. You told it right. So it's the area of the outer rectangle. Outer rectangle is outer radius, capital R. And outer circle. Outer circle is outer radius, capital R. And inner circle is inner radius, small r. So area of outer circle is pi capital R square. Area of inner circle is pi small r square. So when you take out pi common, you get r square minus r square. So this is the formula to find the area of the shaded region here, which is called a ring. So area of one ring is pi r square minus r square. So area of two rings will be 2 into pi r square minus r square, square units.
Okay, ma'am.
Now understood or okay?
Understood, ma'am.
Now what was your doubt? Why it is 2 into, is it?
No, ma'am, like 2 into pi into 96 by 4, no, ma'am. Can we cancel the 4 and 2?
Where? Here, huh?
Yes, ma'am.
You can cancel what? 4
4
and?
2.
Yeah, you can. You can cancel because it's multiplication of 2 into pi into 96 by 4. You can cancel. You'll get the same answer.
Okay,
You can cancel. Yes. Anything else? Swati and Bhavishya?
no doubts, ma'am.
No, ma'am, no doubts.
Fine. Let's try this question now. That's all in the test for today. How many square meters of metal sheet is required to make an open cylindrical drum of radius 63 meters and height 10 meters? Also find the cost of the metal sheet at rupees 200 per meter square. How many square meters of metal sheet is required to make an open cylindrical drum? It's a drum. So if it is open, where is it open, children? It's a drum.
The top. On the
The
top,
top
is
is open.
Top
Yeah. Yeah. Open cylindrical drum does not mean that the top and the bottom is open. If the bottom is also open, then how is it a drum? It's a drum, so the bottom is closed. Open meaning the top is open. Okay. So how many square meters? Meaning what area? When they say how many square meters, that means they're asking you to find the area. What area? See, that's why they're saying square meters. Square meters meaning area. What area of metal sheet? The question is what area? How many meaning what? Square meters area. What area of metal sheet is required to make an open cylindrical drum? Cylindrical drum. Cylindrical, so you got the shape. Drum. So it's closed at the bottom. It's open at the top. Radius and height is given. For the cylinder, radius and height is given. So you can easily find the area. After finding the area, 1 meter square is 200 rupees. Supposing the area is 100 meters square. 1 meter square, 200 rupees. 100 meters square, 100 into 200 rupees. That's all. So what you should understand is, please write, when you write the question, underline how many and write what on top of it. And underline square meters and write area on top of it. So read the question like this. What area of metal sheet is required to make, okay, the cylinder or the cylindrical drum? So you know radius and height, so you can find the area. Then area multiplied by this rate, 200 rupees, will give you the total cost. Yes, children. So tell me the formula to find the area. The area of metal sheet.
And the area of the curved surface plus the area of the top face, bottom face.
Top face and bottom face, huh?
No. Top face, it's not top face, bottom face.
Only the bottom, yeah, because it's open at the top. There is no material there. You don't need the metal sheet to make the top because the top is open. Where are you using metal sheet? Along the CSA. Where else are you using the metal sheet? To cover the bottom. You are not using the metal sheet for the top because it's open. So the area of metal sheet is equal to CSA of the drum plus the area of the circle below. Yes, children. I just started for you. You complete it. Write down the question. So what's the formula to find the CSA? Yeah, what's the formula to find the CSA?
2 pi r h.
2 pi r h. And what about the area of the bottom?
Pi r h.
Pi r square.
Pi r square is a circle, so pi r square. So 2 into 22 by 7 into radius 63 into height 10. Plus, here also you don't have to substitute for pi if you want. You can substitute once for all. So let me do it like that also for you. You can do it once for all. See 2 pi r h plus pi r square. So 2 into pi into radius 63 into height 10 plus pi into r square 63 into 63. So this is going to be 63 into 20. 1260 pi plus 63 into 63. 3969. 3969 pi.
Ma'am, I'm getting like 16,434 now.
Yeah, let me check. 747 into 22. Yeah, 16,434. Very good. 16,434 unit centimeter square. Correct?
Meter square, ma'am.
Wow. Oh, meter square. Meter square. Yeah. Yeah. So 16,434 meters square. This is the area of metal sheet you need to make this drum of radius 63 meters and height 10 meters. Now you need to find the cost. You have to go to the market and buy so much of metal sheet. You need to purchase 16,434 meters square of metal sheet. So what will be your total cost? So the shopkeeper says for 1 meter square, you'll have to pay him 200 rupees. For 2 meters square, you'll have to pay him 400 rupees. 3 meters square, 600 rupees. Then for 16,434 meters square, you will pay him 16,434 into 200 rupees. So
And 32 lakh 80 and 32 lakh 86,800 rupees.
Okay, yeah, I'll just work it here, children. The next step, okay, cost of metal sheet. Cost of metal sheet is equal to 16,434 into 200 into 200. That is area. So that is area into rate. Sorry. You can just write area into rate is equal to area. Area into rate per meter square. Rate per meter square. So that is 16,434 into 200. That is equal to rupees
3 lakh 32 lakh 87,000.
32 lakh 86,800.
Yeah, correct. 32 lakhs 86,800 rupees. So much is the cost of buying the metal sheet. Is it understood, children?
Yes, ma'am.
Yes, ma'am.
All right. So I think you all enjoyed these 4 questions. It was a good recap, right, of the important concepts in this chapter. Yes or no?
Yes,
Yes,
ma'am.
ma'am.
Yeah, so I think now the situation of a hollow cylinder is clear to you, and that road roller, because these are very important situations in mensuration. See, everything is important. These are very important. So the situation of a hollow cylinder, then a road roller to find the area of the road, and this one also, how much metal sheet is to be purchased. So all these are very important situations in mensuration. So I thought I'll just test you with these questions. Yeah, both of you did well, children. You recalled very well. Maybe you used the classwork, still you were able to do very well. Nice, children. All right, so that's it for today's session, children. Thank you so much. You may leave the call.
Thank you, ma'am.
Thank you, children.